Welcome to this management science tutorial for Computer Lab 8. In this Computer Lab we are going to look at a coffee shop, which has got one queue and one server. We have observed data. Okay, you can download this data. Once you have downloaded this data, you should have a sheet like this one, which shows you the arrival time for each customer and the start time and the departure time. So what does that actually mean? So customer 1 arrives 43 seconds after our observations have started. Since there is no queue in the waiting line system, so there is no queue in front of the server, so he can go immediately to the server and order his coffee. After 31 seconds he got his coffee. Good. Then we wait and observe a second customer arrives at the time 6 minutes and 6 seconds after our observations have begun at time 0. The queue is again empty. That means immediately he goes to the server, orders his coffee, and after 4 minutes he gets his coffee. Good. Then customer 3 arrives and so on. But that's pretty boring, immediately going to the server. Let's see where something happens. Where does the arrival time and start time of the service differ? And when customer 6 arrives, so customer 6 is the first one who actually has to wait a couple of minutes. Okay, so this is the data. What do we want to actually achieve with this lab session? We want to derive some fundamental characteristics which we will use in a later tutorial for waiting line systems. So these fundamental characteristics for waiting line systems are the arrival rate and service rate. So this is our main objective of the tutorial, to know how can we actually get these values from observations. Okay, so what are we going to do? We are going to compute the interarrival time between customers, service times. Then we are going to look at some overview data, so the range of the previously determined times. And then we are going to convert times to rates, which gives us then the utilization of the system. And after that we are still going to have a little bit more fun and actually look at the probability distribution, actually to be more precise, just at the histograms of the interarrival times and the service times, which are those histograms. What have we given? This is what we have got: the arrival time and service time. So let's immediately begin. So let's just remind ourselves, so these are the customers, which arrive, so 1, 2 and so on. How many customers do we actually observe? Could be the same customer, but we make 300 observations that a customer arrives in the system. Okay. Good. So the first interarrival time is a little bit difficult because we don't have a 0 customers. We just say this is the time between time 0 when our observations start and the first customer arriving, which is a bit strange that we have got 0 minutes. Why is that strange? Well, because this information is actually given in days, so we have to convert it to minutes, which we simply do by multiplying by 24 hours are within a day times 60, because an hour has got 60 minutes. Okay, 0.71, that makes more sense. So 43 seconds are 0.71 minutes. How can you actually get this minute format? You just click on Format Cells, which you couldn't see here, but you just select it from the drop-down box. Go on Custom Format and write that string down into the type field, and you have got the same format as me. Good. So the first one was a special case. Let's see the second interarrival time. So that is between customer 2 and customer 1. And again, I have to multiply that with my 24 times 60. And I luckily Excel corrected my formula. 24 times 60. So the time between those two arrivals is 5.39 minutes. So I'm going to do that for the remaining 298 observations. And at the end I should have something sensible as well. Let's check that. Yes, everything is within the range. Good. So this completes our first task, so we can immediately proceed to our second task to determine the service times. So what do we do? Roughly the same. We multiply with 24 times 7 something. What do we multiply with that? Well, what is the service time? This is the start time of the service, and this is the departure time from the service, and that means also from the system. So we are going to subtract this 1 minute minus the 43 seconds, and obviously we don't want to forget the multiplication of 24 times 60. Half a minute. Perfect. 10 minutes minus 6 minutes, 4 minutes. Perfect. That completes the second task. Now the third task means that we are going to look at the interarrival time and try to describe it a little bit in more detail. So first, what is the minimum interarrival time between customers? So let's have a look at the minimum interarrival time. So let's have a look at all the 300 interarrival times, and we have got 0, a very small number. I'm going to drag this formula, so that means I'm going to make first an absolute cell reference. Click F4 and you get the absolute cell reference, and now when I drag this formula you will see it's going to be identical, otherwise I would have swapped the column if I wouldn't have fixed it. Good. So why did I drag that? Because I want to reuse that formula, and partly at least the string here, and replace it with max. Okay, excellent. So the maximum is 51 minutes. That means it can take up to almost an hour until the next customer arrives. That's quite a long break for the employee. Okay, now let's look at the service times. So since I've dragged and dropped these formulas, I'll need to make sure that I'm computing the right stuff. So again, the minimum is pretty low, and the service time, the maximum is 38 minutes. So that's a pretty long service time, obviously, so it must have been a very interesting customer to be serviced or a very interesting coffee to be made. Obviously, we can also have that all in hours. We just divide everything by 60 and got it in hours. So Control C, Control V. So 38 minutes. Yeah, all seems reasonable. The unit does not seem so reasonable. So format cells, custom. Let's get rid of that. 0.0 and hours. And okay. Looks all good. So we have got the ranges now. Obviously, it would be interesting what is the average interarrival time. Well, let's just say average. Tab and select all the cells. Enter, and we've got the formula 8:59 minutes. And the service time is on average 6.44 minutes, which is a good indication of a stable waiting line system. Let's convert these minutes also into hours. So 8:59 divided by 60. So 0.14 hours it takes to serve one customer. So hours per customer. So these were minutes per customer on average, and hours per customer on average. Which means we have now completed task 3 and task 4. Now we are in the position to actually do the most important part of this tutorial, to compute and derive the arrival rate and service rate. So these are key input parameters for waiting line systems. So what is the arrival rate? Well, we know the interarrival time, and the relationship between interarrival time and arrival time is just 1 over the interarrival time is the arrival rate. So it's always the inverse. So 0.14 hours per customer gives us 7 customers per hours are served, and 0.11 hours it takes for one customer. So 1 divided by that means roughly 10 customers per hour, which makes sense. So if every 6 minutes one customer comes, then we should have 10 customers per hour. So this verification pretty much works. Now, this gives us the possibility to actually compute already the utilization. The utilization is nothing else than the arrival rate divided by the service rate. And we have got a 75% utilization of our waiting line system, which means that the server operates 45 minutes in an hour and has 15 minutes break time on average, obviously. So that looks like a pretty stable system. Okay, this completes our task 5 to task 7. Now our last task is to actually create some histograms to look at what is the distribution of these interarrival times and service times. So also these are the input parameters. However, that only works if these follow a special distribution. Okay, let's have a look at the histograms, which give us an idea about the distribution. So a histogram means that we are going to count how many times is something in and time interval in this case. So we know that the maximum interarrival time is 52 minutes. Okay, so let's see how many of these occurrences do we have. So we want to put them into bins, into the bin between 0 and 2 minutes. How many interarrival times did we observe that are in this region? So we've got one interarrival time which is between 0 and 2 minutes. Then these are not. There's another one, 2. So suppose we will have quite a few. Here are a couple of more. So this would all fall into that bin. Okay, let's count. So there's the count function. So if I count all of them, all my observations, then there should be 300. If I count only the ones which are smaller than 2 minutes, then I've got, then I don't know how many I've got, but I know it in a second. Count if. So count if, that means I'm going to count something, the interarrival times. I'm going to fix that absolute cell reference again, and say the criteria is if they are smaller than 2 minutes, tell me how many have I got. And so I've got 71 interarrival time which are less than 2 minutes. Okay, I want to have more. So this is the bin, 0 between. So I want to have more of these bins. I want to know between 2 and 4 minutes, between 4 and 6 minutes, and so on, up to okay, let's do that again. Up to 52, because our maximum is 50 for the interarrival times. For the interarrival time. Okay. So if I drag that down there, I've got the same. So I need to integrate some flexibility. So let's not say smaller than 2, but let's do the 2 dynamically and just say smaller than 2. And if I drag it down, then we should have smaller than 4. Yes, perfect. And so on. And what do we observe? The number increases up to 300, and we have had 300 observations. So, so this is some kind of aggregated count. But what we actually want is to have them exactly in the bin between 0 and 2 and 2 and 4, not just smaller than. So we want to have the frequencies. So the first one obviously is the same, but the second one is nothing else than the difference between the one and the previous one. So if that all works out correctly, then we should have 300 observations. Let's just double check that this sum is really 300, and indeed it is 300. So we have got now our frequencies, which means we can immediately create a histogram. Okay, let's create a histogram. So insert a bar chart. Okay, well, doesn't look too pretty. First of all, we don't have any title, so let's say that's our histogram for the interarrival times. Interarrival times. And well, the horizontal axis is not correct, so let's select the data. for the horizontal axis, and well, actually we don't really have good labels, so let's create some labels. Okay, so we are going to create some labels. Let's move that a bit. So we want to have that as an interval. So what does that really mean? We would like to have a string like this is between 0 and 2 minutes. So this is the interval, the bin. Okay, let's create that via string operations. So the square bracket, and then we want to have this number, and then we want to have a comma, a separator, and then we're going to add the next number. And since this is an open interval, we have to have a round bracket to close it. And voila, we have got our label. Good. Now we can go back and select data and edit the label, and just go there, select it, say OK, and find the figure again, and we have got nice beautiful labels. That's nice. Let's just have a little bit more of a good cool design. So this looks already much better. I don't like these big gaps, so I'm just double clicking on the bars and change that to a gap size of 5%, which looks pretty good. It's dark color. I don't like that either, so let's have a bit of more bright color. And now this graph is covering everything, so let's just resize that a little bit and place it somewhere where it doesn't cover all our information. Good, down here, that's a good place. This horizontal axis look now not good anymore. Let's just resize it a little bit and change the orientation. Much better. And that looks like a reasonable graph. So what can we say about that? Well, we could say this distribution is definitely not a normal distribution. Looks like an exponential distribution. Okay, let's have a look what we do with the service distribution. So it's pretty much exactly the same what we have done already. So I'm just going to copy what we have done for the interarrival time, for the service time. Note that the service time only goes to 38 minutes, so I'm just going to go to, well, 40 minutes to cover the last point as well. Copy that and adjust the column width, and obviously now we have to see what has changed. So what has changed? So the aggregation function is now over the service time, not over the interarrival time. So I'm going to drag the box to the service time. And double click. Everything else updates. Perfect. So I have got my service times. So again, that graph is already pretty good. I'm just going to copy that, put it underneath, and rename it to service times. Furthermore, the data source has changed now, so select the data. So we are going to select the data for series 1. So I'm going to select that from here, the frequency column. So all the way down to 40, and hope that the horizontal axis updates automatically. Yes, it does. Great. So now I have got my service time histogram, and it looks very similar to the above one. Now let's just change the color to make sure that it is really something else. So is it something else? 70, 90? Okay, so indeed the values are different. Obviously it's a bit misleading because this one is actually much shorter, only goes to 40. So that would be a better reflection of the size. And again, this distribution looks like an exponential distribution. So that means, since we have got the arrival rate, service rate, and we think, well, we could actually prove that it is an exponential distribution, we have found our celebrated MM1 waiting line system, which we will hear in a later tutorial. I hope you enjoyed this tutorial, and I'm looking forward to seeing you to the next one.